Welcome back. Yet another new topic, and that is resistivity. In the previous classes, we have already discussed about the resistance, its unit, Ohm's law, and associated things with Ohm's law. So today we will be discussing another similar topic with resistance, what is called as resistivity. But before going to that resistivity, let us recall what is resistance. So resistance is the property of a conductor due to which it resists the flow of current through it. So resistance is a property due to which electric current always find some kinds of resistance. Means you can say some kind of trouble to pass through a conductor. Always an electric conductor gives an opposite force so that the current, that is the charges, the electrons cannot pass through the conductor. So that ability of a conductor to resist the flow of electrons through a conductor is called as the resistance, and its SI unit is called as ohm. We have already discussed it. But today we are coming to discuss resistivity. And what is resistivity? It is the measure of the resisting power of a specified material to flow of electric current. So actually resistivity is a measure that will help you to find out the resisting power of a specified material to the flow of electric current, and its unit is ohm meter. So we will understand what is resistivity if we discuss the following things. So you see, resistance of a conductor depends on certain things what we have discussed already. The resistance of a conductor depends on the temperature. It depends on the nature of the material used to make the conductor. It depends on the length of the conductor, and at the same time it depends on the cross-sectional area, that is the thickness of the conductor. But the question is how the length and thickness of a wire depends on its resistance. We have to discuss it. So experimentally it is found that resistance of a conductor, that is R, it is directly proportionate to its length, L. If R is the resistance and L is the length of the conductor, mathematically we can represent it as R is proportionate to L. Means if the length of the conductor increases, then the resistance of the conductor also will increase. And similarly, if the length decreases, resistance will decrease. So length becomes double, though resistance also will become double. Again, resistance is inversely proportionate to its area of the cross section. That is to say, area of the cross section means the thickness. Now if we assume this is the conductor, then this surface is called as cross sectional area. This spherical round shape, that is this part is called as cross section. So that is said that resistance is inversely proportionate to the cross sectional area. Means if the cross sectional area is bigger, means if the wire is thicker, then resistance will be less, and if the wire is thin, then the resistance will become more, and that is why it is called as inversely proportionate. So we can say that resistance R is inversely proportionate to area of the cross section. So we have got two relations. First is resistance is directly proportionate to the length, relation, equation 1, and resistance is inversely proportionate to cross sectional area. This is another relation, and this is equation 2. If we combine equation 1 and 2, that is R is proportionate to L and R is proportionate to 1 by A. By combining them, we will get R is proportionate to L by A, where L is the length of the conductor and A is the cross-sectional area. Now, if we change this relation into an equation, then we will get R, that is resistance, is equal to rho L by A. This rho is a constant. By using that constant, we have converted this relation into an equation, and here this rho, which is a constant, is called as resistivity. So we have got that R is equal to rho L by A. Here rho is called as the resistivity of the conductor. Now what is that resistivity? Let us discuss it in terms of this diagram. Here we are considering a conducting wire. This is the conductor. This is the conductor. And the speciality of the conductor is that the length of the conductor is 1 meter. This is 1 meter long wire. The length should be 1 meter, exactly 1 meter. And the cross-sectional area on either side, it is equal to 1 meter square. So this is a particular type of conductor whose length is 1 meter and its cross-sectional area is 1 meter square. Now we have got here L is equal to 1 meter and A, that is cross-sectional area 1 meter square. If we put the values of L and A in this equation, L and A, then we will get R is equal to rho 1 by 1, because L is 1 and A is equal to also 1. So in this equation, since R is equal to rho 1 by 1, so finally we will get R is equal to rho. What does R represent? R represents resistance. And what is the rho? Rho is the resistivity. So we have got a very special thing here, that if you can take a conducting wire whose length is 1 meter and cross-sectional area is 1 meter square, then the resistance of the conductor is its resistivity. That is, the resistivity is the resistance of a conductor of 1 meter length with a cross-sectional area of 1 meter square. So that is resistivity and unit of resistivity, because in science whenever we are going to measure the resistivity of any conductor, then we have to use them in terms of unit. So what is SI unit of resistivity? So we have here formula R is equal to rho L by A. This is the formula we are repeating. R is equal to rho L by A. Thus you will get rho is equal to RA by L. That is resistivity, rho is equal to resistance into area of the cross section of the conductor divided by length. From this mathematical relation we are getting it as a corollary that resistivity is equal to resistance of the conductor into its cross sectional area divided by the length of the wire. That is, rho is equal to R into A divided by L. R into A divided by L. Now unit of resistivity, unit of rho definitely will be unit of resistance into unit of area of the cross section divided by unit of length. And we know they are units. Therefore unit of resistivity, what is the unit of resistance? It is ohm into unit of area of the cross section, meter square, divided by unit of length is meter. So we are getting unit of resistivity is equal to ohm into meter square by meter. By cancelling meter, we are getting unit of resistivity is ohm meter, and it is represented with this symbol. So this is what is about the resistivity. Thank you.